Welcome back to the Deep Dive. We're here to break down complex topics and give you the insights you actually need.
That's the goal.
And today, we're plunging into something huge, a relationship that's really reshaping, well, everything around us, artificial intelligence and automation. We tend to use these terms, almost interchangeably, but they're actually quite distinct concepts.
They are, and they're converging now in really fascinating ways.
That's our focus today.
Exactly. Our deep dive is all about cutting through that confusion. We're going to precisely differentiate AI from traditional automation, then explore their powerful modern synthesis, this idea of intelligent automation.
Right.
And finally, unpack the, frankly, sweeping implications across industries, the economy, and, society itself.
Right. Our mission here is to give you that shortcut, get you well-informed, hopefully with some surprising facts, maybe a few aha moments, so you can navigate this whole complex tech landscape with a bit more clarity and confidence.
Okay, so let's jump right in. This common confusion. We use AI and automation almost synonymously. What's the core, the fundamental difference?
That's absolutely the place to start. Because the distinction is, well, it's crucial. Think of traditional automation like a very precise, maybe a highly specialized tool.
Okay.
At its core, it's about using equipment, systems to perform specific, unchanging tasks. Without human intervention, usually. You can see its roots way back. Ancient mechanical devices like water-powered trip hammers in China, automating repetitive physical stuff.
Right, mechanical actions.
Exactly. Fast forward to now, the digital age, and you have robotic process automation, RPA. It does similar things, but for digital tasks. Think automatically filling out forms online, extracting data from spreadsheets, that sort of thing.
Okay, so rule-based.
That's the critical point. Traditional automation rigidly follows a predefined static set of rules. It's brilliant at those specific predictable tasks. But it hits a wall, when it faces exceptions or unexpected changes. It doesn't think, it just executes the script. Okay, so automation equals fixed rules, a set playbook. Got it. So here's where it gets really interesting with AI. How does AI break free from that?
AI is, it's a much broader field, more dynamic. It's focused on creating what we call smart agents.
Smart agents.
Yeah, systems that can reason, learn, and act autonomously. The key contrast with that traditional automation is that AI-enabled systems are designed to dynamically respond to new information. They make interpretive decisions. Its main characteristics are learning from experience, using logic to draw conclusions, solving complex problems. So, a concrete example. An automated system emails a receipt after you buy something online. That's a set rule. Always happens. An AI system, though, might analyze huge amounts of customer data or classify images it's never seen before or make predictions about future sales based on patterns it's learned.
So it's finding the pattern itself.
Precisely. The fundamental difference is automation follows rules. An AI system is given a goal, and then it autonomously designs, adapts, refines a workflow to achieve that goal based on the context, the data it sees.
Okay, so if I'm getting this, traditional automation is like a really good screwdriver, does one job perfectly, but AI is more like a whole toolkit that can figure out which tool to use or maybe even invent a new way to fix something if the problem changes.
That's a great analogy. You've really nailed it there. It's a profound shift.
And what's fascinating, as you said, is despite these differences, their histories are really intertwined, like parallel tracks heading somewhere together.
They really are linked. I mean, the human dream of creating intelligent machines goes back millennia, ancient automatons. Even the word robot that was coined by Karel Apek in his 1921 play, Rossum's Universal Robots. From the Czech robota, meaning forced work.
Wow, 1921.
Yeah. But modern AI as a field was really formally established later, in 1956, at the Dartmouth workshop.
Yeah.
John McCarthy popularized the term artificial intelligence there. And that era saw huge foundational work. Alan Turing's imitation game in 1950, questioning machine intelligence.
Yeah.
LISP, the first AI programming language, in 58. The term machine learning itself was coined in 59.
So the ideas were brewing.
Absolutely. And interestingly, right alongside this, the first industrial robot, Unimate, started working on a General Motors assembly line in 1961.
So practical automation and AI theory were developing side by side.
Exactly. And then you had the first chatterbot, Eliza, in 1966, exploring language.
But it wasn't all smooth sailing, right? I remember hearing about an AI winter. What happened? And why is this current boom so, different?
The AI winter. Yeah, that was a tough period, late 80s, early 90s. Funding dried up. interest waned. It was largely because the promises were huge, very ambitious, but the actual capabilities of the tech just weren't there yet. Plus, it was expensive.
Right. The hype outpaced the reality.
Exactly. The underlying tech, the computing power, the data,
Yeah.
it wasn't ready. What makes the current AI boom, which really kicked off around, say, 2012, so different is this powerful convergence. We now have absolutely massive computational power available relatively cheaply. We have these vast data sets, big data. And we've seen this surge in consumer-facing applications that really drove practical development forward.
Yeah.
We overcame those earlier limitations.
So it wasn't a failure, more like a necessary pause for the tech to catch up.
You could definitely see it that way, a period of incubation almost.
Okay, so what does this convergence mean now? It seems they're not just distinct anymore, but powerfully synergistic.
That's precisely it. We're now firmly in the era of intelligent automation, or AI-powered automation, people call it both. This is where AI provides those dynamic decision-making skills that traditional automation always lacked. It creates a fundamentally different way of operating.
How so?
Well, think about that assembly line robot again. Before, fixed instructions. Now, with intelligent automation, it can use AI to learn. It can adjust its movements in real time to avoid an unexpected obstacle, maybe even work collaboratively with a human nearby. It optimizes its own performance based on real-time data feeds.
So it's not just faster, it's smarter, more adaptable.
Exactly. It's about changing the nature of error, the nature of learning in these processes. Imagine a factory floor where machines don't just do tasks, but they continuously optimize themselves based on tiny variations, things a human might miss. They eliminate bottlenecks before they even happen. That's a game changer.
That really paints a clear picture of what intelligent automation is, this synergy. Okay, but to really grasp the impact, let's look at where it's happening. Where are we seeing the biggest transformations? Let's start with manufacturing, the bedrock.
Good place to start. In manufacturing, AI is shifting operations from being, reactive fixing things when they break to being truly proactive. Take predictive maintenance. Instead of waiting for a machine to fail.
What's this costly?
Hugely costly. AI analyzes real-time sensor data, maybe vibrations, temperature. It detects tiny issues before they escalate into breakdowns, so you can schedule maintenance optimally, prevent that downtime. It boosts uptime dramatically.
In quality control.
Another big one. AI-driven quality control is revolutionizing inspection. Manual checks are slow, prone to human fatigue and error. AI vision systems can inspect products on the line in real time, identifying the tiniest defects with accuracy and consistency far beyond human capability.
Okay, moving to healthcare, it sounds like AI isn't just automating tasks there, but almost creating a kind of super intelligence for doctors, especially with data.
That's a really good way to put it. AI in healthcare enables entirely new capabilities. It really augments human expertise. It can analyze just vast patient data sets, identifying subtle patterns that might indicate disease much earlier, more accurately. Especially in medical imaging x-rays, CT scans finding signs of cancer or neurological disorders that might be missed.
Wow. And personalized medicine.
Yes, that's another huge area. AI analyzes genetic info, patient history, lifestyle factors to create truly tailored treatment plans, moving beyond that one-size-fits-all approach to something much more effective for the individual.
And drug discovery, I hear that's accelerating.
Massively. AI can sift through potential molecules, predict their effectiveness, their side effects with incredible speed. It's significantly cutting down research timelines that used to take, years, even decades.
Okay, the financial sector. Always data heavy, super fast paced. Seems like a natural fit.
Oh, absolutely. Finance is being reshaped by this. AI is redefining risk management, optimizing operations at speeds unthinkable before. Think real-time fraud detection, analyzing transaction patterns instantly to flag suspicious activity, preventing massive losses.
Right, before the money's gone.
Exactly. It's also central to algorithmic trading, executing complex strategies in milliseconds, and automating credit risk assessment. This creates much more dynamic, responsive risk systems compared to the old static models. More precision, more speed.
And customer-facing stuff, too.
Definitely. AI-driven chatbots handle customer queries 24/7. Robo-advisors are making wealth management accessible to far more people, reducing operational costs.
Okay, finally, transportation. We all see autonomous vehicles creeping closer to reality, but it's bigger than just self-driving cars, isn't it?
Much bigger. The focus in transportation is heavily on boosting safety and efficiency across the board. Autonomous vehicles are the obvious example, yes. Using sensors, machine learning to navigate, avoid obstacles, handle complex situations.
Like Tesla's work.
Exactly. Companies like Tesla are pushing the boundaries with advanced AI for vision, planning, training these deep neural networks on immense data sets. That's a huge leap for safety, potentially. But beyond self-driving cars, AI is improving navigation and logistics for everyone right now.
How so?
Think Google Maps or Waze. They use sophisticated AI algorithms to process real-time traffic, weather, historical patterns
Yeah.
to give you the optimal route, saving time, saving fuel, leading to smarter traffic management for entire cities.
These applications really are transformative, reshaping whole industries. But let's connect this to the bigger picture. What does it mean for the economy? And the question on many people's minds, what about my job? Are we looking at mass displacement, or is it more complicated?
That is the critical question. And it starts with what some economists call the productivity paradox. On one hand, AI and automation are undeniably driving huge gains in productivity, efficiency, stimulating innovation. You see studies like from McKinsey estimating AI could add something like $13 trillion to the global economy.
13 trillion, wow.
It's staggering. And generative AI tools specifically, they've been linked to maybe a 66% increase in employee productivity in certain tasks. So economically, AI looks like this powerful engine for expansion.
Okay, impressive productivity numbers, but then we constantly hear the headlines, robots are taking our jobs. How do we square those two things?
It's a deeply nuanced picture. It's not straightforward. Yes, you have projections. Goldman Sachs estimated up to 300 million full-time jobs globally could be exposed to automation in some way. McKinsey projected maybe 400 million workers globally could be displaced by 2030 due to automation. Those numbers sound scary.
They do.
But, and this is crucial, you have to balance that. The World Economic Forum, for instance, predicts AI and automation could also help create 59 million new jobs by 2028.
Ah, so creation alongside displacement.
Exactly. It's not a simple zero-sum game. It's a profound shift in the labor market.
So it's not just jobs vanishing, it's work itself changing. What's the key distinction then? You mentioned automation versus augmentation earlier.
That distinction is absolutely critical. Automation is when AI completely replaces a human task. Think of machine sorting packages instead of a person.
Okay.
Augmentation is when AI enhances a worker's productivity, like a doctor using AI to analyze scans faster, making them better at their job.
Right, a tool.
Exactly. And the data suggests the negative impacts on jobs are really concentrated where AI automates tasks away.
Yeah.
But professions where AI serves as an aid, a co-pilot, think collaborative robots, cobots, working alongside humans, those jobs seem stable or even growing.
So the evidence suggests AI transforms tasks within jobs more than it eliminates entire roles.
Largely, yes. That seems to be the trend. Tasks change, skills required change, but maybe not total elimination across the board.
Okay, that leads to a crucial point, though, about the polarization of work. Who's feeling this transformation the most? Are certain groups more vulnerable?
This is where the impact gets much more targeted.
All right.
And it raises serious equity concerns. There was a really interesting study from Stanford University. It showed that since late 2022, AI adoption has led to about a 13% drop in employment for young entry-level workers.
Young workers specifically, ages 22, 25.
Exactly, in jobs highly exposed to generative AI tools.
Mm-hmm.
But older, more experienced workers in those same roles, their employment held steady.
Why the difference?
Well, the thinking is that entry-level jobs often involve more routine, process-driven tasks. Basic coding, data entry, writing simple emails, things generative AI is getting quite good at quickly and cheaply.
Right.
More experienced workers tend to do higher-value stuff, strategic decisions using institutional knowledge, complex human judgment, things AI still struggles with.
So it's hitting the first rung of the ladder hardest. That has long-term implications.
It really does. And it's not just about age. It seems to be potentially exacerbating existing inequalities, too.
How so?
Well, another McKinsey analysis found Black workers are overrepresented in those high-risk automation roles, about 24% compared to 20% of white workers. That could widen racial economic gaps. And an International Labor Organization study predicted about 7.8% of women's jobs in high-income countries could be automated versus only 2.9% of men's jobs.
So the impacts aren't evenly spread at all.
Not at all. The effects seem highly localized, concentrated. They disproportionately affect already vulnerable groups. And it could create this long-term talent gap if young people can't get that initial experience.
Okay, the economic shifts are clear and complex. But with this kind of power, there's always the shadow side, right? The ethical questions. And these aren't just abstract debates, are they?
Not at all. These are very practical, often technical problems we're facing now and how AI is designed and deployed. Let's start with algorithmic bias. This isn't some vague concept. It's a direct result of technical choices.
Where does it come from?
It can creep in multiple ways. Skewed training data is a big one. If the data reflects historical biases, the AI learns them. Flaws in the algorithm's design itself, or even the unconscious biases of the people creating the data or the models.
Like the hiring example.
Exactly. If an AI hiring tool is trained on past hiring data that maybe unknowingly favored certain groups, the AI will just perpetuate that discrimination.
So how do you fix that?
It requires active effort, collecting diverse representative data, building fairness-aware algorithms designed to check for bias, and continuous monitoring and auditing after deployment.
Okay. Another huge concern, especially given AI's need for data, is privacy. How do we balance innovation with our right to privacy?
Data privacy and security are absolutely paramount. AI models, especially deep learning ones, need vast data sets to train. That raises huge questions about collecting personal info, sometimes without clear consent, how transparently it's used, and the potential for mass surveillance, especially with things like facial recognition in public spaces.
Are there technical solutions?
There are promising approaches. Things like federated learning. This lets the AI model learn on your local device, your phone, say, and only anonymized aggregated insights get sent back, not your raw data. And differential privacy. This adds a tiny bit of statistical noise to the data, making it extremely hard to re-identify any single person while still letting the AI learn the overall patterns. But tech alone isn't enough. Governments, regulators need to set clear rules, strong privacy protections.
What about the black box problem? If we can't understand why an AI made a certain decision, how can we trust it or hold it accountable?
That's a really thorny issue. The black box problem refers to the opacity of many advanced AI systems, deep learning models especially. It's often a huge problem. Think criminal justice, loan applications, medical diagnoses. If an AI makes a decision that negatively impacts someone's life, and you can't understand the reasoning, how can that person challenge it? How do you ensure fairness? How do you assign accountability if something goes wrong?
So what's the answer? More transparency.
Transparency is key. We need clear governance structures for AI development and deployment, rigorous algorithmic auditing, and a big push towards developing explainable AI, or XAI, techniques specifically designed to make AI decision-making processes more interpretable to humans.
Okay, beyond these sort of technical ethics, there are broader societal impacts too, right? Things touching on our well-being, maybe even human dignity.
Absolutely. We're seeing research emerge on the psychological side. Some studies show working closely alongside robots can lead to lower job satisfaction, feelings of isolation for human workers, even if the physical work is easier.
Interesting. Less human interaction.
Potentially, yes. And then you have the complex ethics around social robots, using them for elder care, for example. It raises questions about genuine consent, especially with vulnerable populations, and whether we're okay with technology potentially replacing authentic human connection and care.
Tricky questions.
Very. Ultimately, public acceptance of AI hinges on trust. That requires open dialogue, culturally sensitive ways of adopting these technologies, and then perhaps the most profound ethical debate is around lethal autonomous weapons, LAWs.
Killer robots, basically.
Essentially, yes. Weapon systems that could select and engage targets without direct human supervision. There's a huge international debate, including at the UN. Many argue that removing human judgment from life and death decisions crosses a fundamental moral line. It violates human dignity.
Okay, so we've covered the definitions, the applications, the economic shifts, the ethical minefield. Given all this complexity, what does the future look like? What's coming next?
Well, the evolution is accelerating. We're looking at the next generation of large language models, things like GPT-5, Google's Gemini. They promise significant leaps in capability, but also, hopefully, in safety, accuracy, reducing those factual errors or hallucinations.
Making them more reliable.
Hopefully. We're also seeing changes in how we interact with AI for creation. Things like vibe coding in software development.
Vibe coding?
Yeah, it's this idea where developers move beyond rigid code syntax. They can just describe the feeling or the function they want in plain language, and the AI translates that vibe into working code. It could radically speed up development.
Wow. And in robotics?
The big trend there is towards general-purpose, bipedal humanoid robots, like Tesla's Optimus or Figure AI's robots. These are designed not for one specific task, but potentially a wide range of unsafe, repetitive, or just boring jobs currently done by humans. They require incredibly sophisticated AI for balance, navigation, interacting safely with the physical world. That's a huge software challenge.
It seems like governments are scrambling to keep up with all this. What does the global regulatory picture look like? Is everyone on the same page?
Oh, far from it. The global regulatory landscape is really a complex patchwork. Different major powers are taking quite divergent approaches, largely reflecting their own national values and priorities.
Like who?
Well, you have the European Union. They've been very proactive, quite prescriptive, with their Comprehensive AI Act. It's the world's first major AI law. It sets a high bar for safety, transparency, accountability, using a risk-based framework, stricter rules for higher-risk AI applications.
Okay, so the EU is focused on rules and rights. What about the US?
The United States has generally taken a more deregulatory, market-driven path, relying more on executive orders, existing agency rules, and state-level laws rather than one big federal law. The priority there seems to be fostering innovation, maintaining global leadership in AI development, less top-down regulation.
In China?
China's approach is different again. It's much more centralized, state-driven, often focused on national security applications. Their regulations tend to be more reactive, often focusing on assigning liability when specific AI services cause harm, rather than broad upfront rules like the EU.
So very different philosophies.
Completely. EU emphasizes human rights and safety. US emphasizes market freedom and innovation. China emphasizes state control and stability. These values really shape their approaches to AI governance.
Okay, connecting this all back. How do we ensure a future that's human-centric, where AI helps us rather than displaces us? What skills do we need?
I think the future has to be about human-centric adaptation and collaboration. It shouldn't be framed purely as displacement. As AI gets better at handling routine, predictable, data-driven tasks, the most valuable human skills become even more important.
The ones AI can't do.
Exactly. Empathy, creativity, critical thinking, complex problem-solving, collaboration, ethical judgment. These are uniquely human strengths. This means our education systems need a fundamental rethink, shifting focus to cultivating these skills from an early age. And policymakers, business leaders, they need to invest seriously on human capital, lifelong learning, accessible workforce training, and reskilling programs.
So businesses should see AI as a tool for augmentation.
The successful ones will, I believe. They'll view AI as a tool to empower their employees, freeing them up from mundane tasks to focus on higher value, uniquely human contributions. It's about a reskilling revolution, really.
So wrapping this all up, what's the bottom line for us as individuals, for businesses, for society, as we navigate this powerful transformation?
Okay, the recap. AI and automation, they started distinct, but now they're converging into this incredibly powerful force, intelligent automation. This brings amazing potential for productivity and innovation, no doubt, but it also brings very real economic challenges, especially localized job disruption for certain groups. And it surfaces these critical ethical issues around bias, privacy, accountability, and even deeper societal impacts.
So the path forward isn't simple. It seems to demand a really comprehensive approach.
It does.
For societies, it means finding the right balance with regulation, clear, adaptable frameworks that foster innovation but have strong ethical guardrails, maybe learning from what different countries are trying. For businesses, it sounds like the smart move is shifting towards that human-centric augmentation model, really investing in upskilling their people. And for us as individuals, it seems it's about embracing lifelong learning, leaning into those skills, creativity, critical thinking, empathy that AI just can't replicate.
Absolutely. And perhaps a final thought to leave you with, as intelligent automation continues its incredibly rapid evolution, maybe we should think about how we measure its success, not just in terms of dollars or efficiency gains, but how much does it actually contribute to human flourishing, to fairness and equity across all parts of society? Something to ponder as you see AI popping up more and more in your own life.